Hey folks, we're going to talk a little more impulse and momentum, including doing several numerical examples. I've rewritten the equations that we talked about in the previous video here, so if you already have them, you don't need to rewrite them. And I'm going to start with talking about this last one, okay? So you can use this one if the force, whatever force we're dealing with, is constant with respect to time. If not, then you would, instead of doing this, you would do this to get the impulse, okay? But for now, let's assume the forces that we're going to deal with just for a few minutes here are constant with respect to time. So this version of the equation you can use to explain a lot of things. Now, there are six things in these two equations combined. There's impulse, there's momentum, there's force, there's time, there's mass, and there's velocity. So there are situations when one or two of those things will change, but the others won't. Okay, so that's something you need to think about. So for example, let's say you are driving along in a car and you hit a brick wall. And don't worry, you're okay. But a lot of damage is done to the car. Okay, the front end gets crushed. Okay, now just for the sake of argument, let's say the car was going 20 miles per hour when you hit the brick wall, and then you come to a stop. Let's say in the second instance, same exact car, same exact speed, 20 miles an hour, but this time you hit a haystack, and the haystack is big enough so that the car does come to a stop. And this time the car is not damaged. So what's different between those two cars? Well, first of all, which one has the bigger mass? Well, I told you they were the same car. So let me rewrite the equation here. So we've got Ft equals delta mv. So they both have the same mass. All right, which one had a bigger change in velocity? Well, both cars were going 20 miles per hour, and both cars were stopped at the end, so they both had the same change in velocity. So if I asked you which one had the bigger change in momentum, okay, so this is I on this side, and this is delta P on this side. Well, if the M and the delta V are the same, well, change in momentum is the same for both cars. Well, which one had the bigger impulse exerted on it? Well, impulse is change in momentum, so the impulse is the same on both cars. So what on earth is the difference? Okay, well, then it comes to this last bit here. The car that hit the brick wall stops very quickly, so this time goes way down. In order to keep the left side of the equation the same as the right side, something on the left side has to go up, and that is force. So when the car hits the brick wall, the time to stop is so short that the force has to be really big, and that's what causes damage, is force. Okay. Now, having said that, there are other examples of that. So, for instance, let's say you're jumping and you're landing. When you land, you usually bend your knees. When you bend your knees, that makes the time longer to stop, and that makes the force of stopping less, and therefore you're less likely to get hurt. Okay. Um, it's the same thing, like an airbag or a seatbelt do the same thing. And both an airbag and a seatbelt, they make the time for your body to stop longer, and therefore make the force to stop your body less. And those help keep you safe. Okay. Now there are other examples where you might want to make one side or the other. Well, they both have to get bigger. So, for instance, let's say you're playing golf. So here's the golf club, and here's the ball. Whether you are hitting a golf ball or a baseball or softball or volleyball, or you're trying to throw something, your coaches will almost invariably tell you to follow through. Well, why do they tell you to follow through? How is this equation? What does this do for us? Okay. Well, following through, what that means is in this equation, and I'll rewrite it again. So we got Ft equals delta mv, and that's impulse is change in momentum. When you follow through, what you're doing is you're staying in contact with the object for a longer time. Okay. Now, if the object's, let's say, a golf ball, the mass of the golf ball is not going to change. So what on the right side is going to get bigger? Well, your velocity. So in this case, you are actually increasing the impulse to increase the momentum of the ball leaving the club or your hand or whatever. Okay. So I will go ahead and do examples on the next video, but I did want to go over some of these concepts with you when you're talking about what changes and what doesn't as far as impulse and momentum. So hope that was helpful. I'll see you in the next one.